In this chapter, we look at the value of information. Now, if we think of a supply chain, often we talk about three types of flows. One is the flow of materials, which typically is a forward flow process that takes materials from the manufacturer all the way through the supply chain down to the retailer until it's finally sold to the customer. We have financial flow, so cash flowing back into the supply chain system where the customer pays for an item, and then we have flows that go from the retailer to the distributor to the wholesaler right back to the manufacturer. In addition to that, we have information flow, where an information flow can be bidirectional in the sense that in terms of a forward flow, we could have information that the manufacturer sends to the wholesaler sells to the distributor, and the distributor sends to the retailer, and so forth. But also, if we think of demand information, so supply information will go forward, demand information will go backwards. So customer demand is seen by the retailer, who then turns around and places orders with the distributor, and then who then turns around and places orders with the wholesaler and then the manufacturer. So we have a backward flow of information. So information plays a really critical role in optimizing the supply chain. If we do not manage that information or use that information effectively, then the planning of the supply chain or sort of developing effective strategies becomes hampered by the lack of effective information. There are different information types, inventory levels, so knowing exactly what is in stock at which locations in the supply chain, the actual orders that are placed one stage earlier, so say retailer orders to the distributor or distributor orders to the wholesaler, and so forth. Production quantities, the current production capacity, excuse me, at a manufacturing plant, the current, production costs, production volumes, etc. All of those pieces of information are quite important. And then, of course, the delivery status of orders. When orders are placed and they are shipped by the supplier, knowing exactly what the status of that delivery is important. So these are all different types of information. So what's the value of information? Essentially, it serves a number of roles. In some cases, it could help to reduce variability in the supply chain, because the lack of information can pose a major problem for planning purposes. If there is a lack of accurate data on the customer demand, then the supplier is simply forecasting in anticipation of that demand. And without good information, good forecasts, that could actually be detrimental to the supply chain. So information allows the various stages to do better forecasting, better accounting, maybe being able to plan promotions and so on. It allows for better coordination between different stages of the system, and ultimately it allows the retailers to serve their customers better, so to sort of maximize service levels. When information is obtained, if that information is used quickly, in some cases, a retailer is able to react and adapt to changing customer demands. And if that is shared with the suppliers, they too in turn could actually respond and react a lot more quickly. Now, there's a concept that plagues supply chains, which is a concept called the Bullwhip Effect. And what it signifies is that while customers have a certain demand pattern, if you actually propagate backwards through the supply chain, you will see that that demand pattern actually gets quite distorted. And the decisions made by the various stages, such as the distributor, the wholesaler, the manufacturer, sometimes is out of sync with what the reality is on the ground with respect to the demand. So these folks are making plans that often requires significant amount of inventory even though the customer demand pattern might not be changing a whole lot. And that was observed by Procter and Gamble, where they noticed that their sales was fairly stable, but somehow the distributor orders fluctuated a whole lot more than what the retail sales were. And then one wondered, why did that actually have to happen? And there's several reasons for the bullwhip effect. Now, if you think of a bullwhip and you crack a bullwhip, what happens is the amplitude of the wave formed by the bullwhip is actually smaller at your hand, and as it goes backward to the tip of the bullwhip, the amplitude gets a lot larger. So in other words, as we go from the retailer back to the factory, we will begin to see as we go backwards here, we'll begin to see higher levels of inventory as we go backwards towards the factory. All right, and it's kind of quite an interesting phenomenon. I don't know if we could see this very carefully here. Here's customer demand on the bottom, and then we begin to see changes in the retailer orders, and then we look at the wholesalers orders next in white. So we see the variability increasing, and by the time you get to the factory, I mean, look at this. This is way up here. So here's the customer demand, but somehow the manufacturer is producing at this level. So this is quite an interesting phenomenon observed by a prof at MIT, where he wanted to look at systems dynamics and the role that information played in supply chain system dynamics. So there are a lot of factors that actually contribute to variability, and that is why you have as you backward propagate into the supply chain, the degree of uncertainty increases, and there are several factors that drive that. So what happens is that if the retailer is trying to forecast customer demand and does not share that information with the distributor is now trying to forecast the retailer's orders. But what happens is that the retailer has a particular ordering strategy, and that ordering strategy might, we're not sure if it's periodic review or if it is a continuous review inventory policy. But what happens is that the distributor will see fluctuation in the retailer's orders, but the retailer is actually reacting to what they perceive to be going on in the marketplace. And if the retailer decides to offer discounts and promotions and so on, that causes a fair amount of variability in customer orders. So now that variability is compounded by the distributor's view of what the retailer is ordering. And then if you go backwards now, so now the distributor is ordering from the wholesaler, and the wholesaler is trying to predict or forecast the orders. But remember now, the variability of the retailer is now incorporated in the orders of the distributor. And so then that variability is carried backward to the wholesaler, and then the manufacturer is now trying to predict what the wholesaler is going to order, and the variability and the uncertainty is now carried even one step further. So as you go back through the chain, that uncertainty is compounded. And remember that one of the ways in which we deal with uncertainty is to carry safety stock, so that the orders that are placed to the supplier also includes the requirement for safety stock. And if you recall the formula for safety stock, the variability of the demand is important. The lead time and the variability of the lead time is also very important. So what happens now is that as that uncertainty increases, you place larger orders to cover safety stock, in which case the inventory level starts to grow significantly as we get back to the manufacturer. There are other factors that contribute to variability. Lead time, of course. The lead time is not always constant. And because the calculation of, say, base stock levels in a periodic review inventory system involves the lead time, then the longer the lead time, the greater the need for safety stock. And so in a case like that, any changes to the lead time affects the safety stock levels, and that then affect the order quantities by the retailer or the distributor and so on. Again, when you backward propagate this, you're increasing the variability as you go backward. So lead time also plays an important role. Now, sometimes, say for example, let's just think of the retailer. The retailer may want to um, sort of order in batch quantities. They're prepared to trade off ordering costs with holding costs. And so if they order quantity Q each time, then they're not ordering consistently. And so what happens is that they're not, if you order Q each time, so that your order quantity is the same. However, the frequency of the orders change depending on the variability in the demand distribution. So what happens in a case like that is, yes, while the distributor or the wholesaler and so on might be seeing an order quantity Q, what happens is that the frequency varies. And so there is uncertainty now in being able to forecast the demand. So you see many periods of no demand, and then actually then there's an order, then several periods of no orders, and then there's an order. So what happens is that there is this sort of distorted view of a pattern of orders, and the wholesaler will try to react to that. Okay, and so that has implications for transportation. It has implications for inventory and production decisions and so on. Price fluctuations also contribute to variability. If you keep offering discounts and sales, then in a case like that, you begin to see some variations in customer orders. All right. Some cases too, retailers try to stock up when prices are lower. So when they do that, if prices are lower, it really affects the consistency of the quantity of orders that someone will place. If the price is now 10% cheaper, you change your order quantity rather than sticking to that fixed order quantity that has been determined earlier. So all of those things, forward buying and so on, getting large orders, small orders, etc., and that's fluctuating over time, really helps to drive uncertainty. Inflated orders happen because you have retailers and so on will tend to inflate their orders because they fear stock running out of stock. So if they just went through a stock out period, to hedge against that the next time, they might actually inflate the order. And so what happens again is that the wholesaler or the distributor sees distorted orders. And because those orders are distorted, they would make decisions around stocking more inventory than is actually necessary. So we begin to see the bullwhip effect propagating throughout the supply chain. So how can we quantify this bullwhip effect? Let's just think of a two-stage process between, say, a retailer and a manufacturer. So we'll just sort of remove the sort of phases in between for now. And assume that there's a fixed lead time L, and that if you place an order at time T, the order will be received at time T plus L, which we're seeing right here. So if the retailer follows what we call a simple periodic review policy, and with a simple periodic review policy, what happens is that the time between orders is fixed. So you might order weekly, monthly, every 2 weeks, every 3 months, etc. But the amount that you order changes each time. So if that is the case, the base stock level, which means this is the target level for your stock, is really the average demand during the lead time plus some safety stock. And if you look here, you'll see that the safety stock is a function of the variability of the demand and the lead time. So any changes in demand variability or perceived variability of the demand could affect the base stock levels, in which case it affects the amount that the retailer will actually order. we have an order up to point. So this is just the mathematical formula for this, where if the retailer is using a moving average technique, this is how the retailer would average or assess the average demand, which is just, if it's a 2-period moving average, use the last 2 periods. P then becomes your number of periods, and you simply add the demands for the last 2 periods and average them. That's a 2-period moving average. P is a 3-period moving average. Then you'd estimate it by using the last 3 periods and then divide it by 3. So what you notice here in this case is that the average demand is changing as the demand patterns are changing, as the demands are changing. And then this is just the standard deviation or the variance, sorry, of the demand, and that you should remember from your statistics course in this case. So these 2 parameters are actually here in what we call the order up to point. And the order up to point, the amount that you actually order, is the difference between the inventory level and that order up to point when the order is placed. Okay, so in a periodic review system, the retailer would look at what inventory is on hand, subtract that from the order up to point, and then place that amount of order. So what if we had centralization versus decentralization? In other words, the decisions that information is shared, and you have a single stage decision making. So the manufacturer in this case will consider making the decision. So if you centralize, what happens is that you have, let var d be the variance of the demand seen by the retailer, but this is the variance of the orders placed by the retailer. The mathematical computation is not shown, but we see that the ratio of those two is 1 plus a factor, and that factor is a factor of the lead time and the number of periods used in the forecast. So if you look at this obviously is greater than or equal to 1, which means that the variance of the orders placed by the retailer will be larger than the actual variance of the demand. So you're already beginning to see this bullwhip effect in play. And notice something. This is a function, a direct function, well, not a direct function, but a quadratic function of the lead time, which means that as the lead time increases, that ratio is going to increase dramatically. And if we, however, if we decrease the number of periods that we use in calculating the moving average, then that also increases as well. So if we could shorten the lead time and increase the number of periods, and if you think of a moving average, the more periods you include in the moving average, the more you smooth the demand. And if you smooth that demand, then there's less fluctuation, there's less variability. That variability is then, that smaller variability allows the manufacturer to not overproduce. And so if you look at these graphs show you that as the lead time increases, the variability or the amount of inventory carried increases significantly. But then if you notice, for all these free functions, as the number of periods in the moving average increase, then the effect of that variability is diminished significantly. So it seems to suggest that you might want to include a fair number of periods in the calculation of the moving average. However, if you did that, while you get the smoothing effect, you're not able to be as responsive because you're smoothing out the demand fluctuations way too much. All right? So this is just an example to show here. In the case of P is equal to 5, L is equal to 1, we have a ratio of 1.4, but when you increase the, if you keep the lead time constant but increase the number of periods, it drops to 1.2. So that's the Bullwhip effect. Now, if instead of having centralization, and you see here that centralization does provide some benefits. If you centralize the information within the supply chain, then every person within the chain shares the demand information. You would get actual, you could reduce the Bullwhip effect. But if we did not centralize, instead we went to decentralize information. This says centralized information right here. So with multiple stages, now, because remember the first example we did just had the retailer and the manufacturer. So if we include the wholesaler and the distributor, essentially what you have is that that ratio is an additive function of the lead time and the number of periods in the moving average. So all we're doing is we essentially including, if we had, for example, the say distributor stage, then the lead time here would just include the lead time to the retailer. But if you had the wholesaler stage, then the lead time here would include, this value would include the lead time between the wholesaler and the distributor, the lead time between the distributor and the retailer, and the lead time between the retailer and the customer. In the case of multiple stages, the formula is just simply modified by calculating a lead time value that is the sum of all of the lead times going forward. All right, and so we could see why now, because that function is increasing, that the variability increases as we get back towards the manufacturer. If we have decentralized information, however, that means the retailers don't share any information. It turns out that the relationship is actually a multiplicative relationship, and so the variability is compounded at each stage, so it's multiplied as opposed to added. So this symbol right here means that we're multiplying. So you're multiplying the value for the retailer with that of the distributor. Then if you go to the wholesaler, you multiply that by the to get to the wholesaler, and then you multiply again to get to the manufacturer. So we're multiplying this value at each stage of the supply chain, and so therefore it has a more dramatic effect on the variability, right? So just a couple of quick managerial insights that allows a supply chain manager to decide what to do is that variance increases up the chain in both systems. However, the variance increases at a slower rate in a centralized supply chain versus a decentralized supply chain. It's additive in the centralized case, it is multiplicative in the decentralized case. Okay, and both systems require a reduction of the bullwhip effect. It cannot be eliminated completely. So let's just look here. If you compare those two, this is the decentralized case where K is equal to 5, and then the decentralized system where you have the lead time is actually 5 as well. All right, and then if we go down here where we have 3, we see, so as we go up, the decentralized variability is increasing at a more dramatic rate. We still have that effect of it decreasing as we increase the number of periods in the forecasting model, in the moving average. All right. So, what can we do with this bullwhip effect? We cannot eliminate it completely, but certainly we can do a couple of things. One is we could consider centralizing information, so that is sharing information between the various supply chain partners. You could also try to find ways to reduce variability in the sort of customer demands. And one of the techniques for doing that, Walmart has pioneered that, which is what we call everyday low pricing. And with everyday low pricing strategy, you don't have these major fluctuations in demand because customers don't have to worry about the prices changing. So as a result of that, you get some stability in the demand function. All right. If you could focus on reducing the lead time, certainly that would help. And there are ways to consider that, whether or not we're talking about using sharing information as a way of giving the manufacturer a heads up or the wholesaler heads up on the orders that is coming, and by doing so they could perhaps manage the buffer stocks a little better so that the product is not necessarily being made from scratch. So a certain amount of it can be made to stock, and then the lead time is shortened from including production to just simply a shipping lead time. All right, so those things can happen by setting up strategic partnerships. So in other words, if the manufacturer is managing the inventory, so if you think about vendor managed inventory as an example, if the manufacturer is actually managing the inventory at the retailer, then there's very little information lead time, because the manufacturer has direct information on what is selling, and in so doing you sort of eliminate the wholesaler and the distributor, and as a result you could pretty much get rid of most of the effect of the bullwhip, that demand variability. So in a sense you could practically eliminate the bullwhip effect if you do vendor managed inventory. Okay. There are some other incentives that can be provided. So you say, okay, let's centralize the information. While it will reduce variability, sometimes it's not always that easy to get, particularly supply chain partners that are independent, where the different phases or stages are owned by different people, and so it's hard to get them to coordinate because they may want to keep certain amount of information private. They fear that their suppliers will share the information with their competitors, and there's still that tendency to want to inflate forecasts, even though you might want to share some information. So information sharing is useful, but we have to ensure that that information is accurate and is not distorted. So one of the ways to actually get retailers to reveal what they perceive as the true demand is through some contract by structuring some of the contracts, and we did talk about that in our chapter on supply contracts. Capacity reservation contract is one of them. So if the buyer agrees to pay a certain level of prepay for a certain level of capacity, what happens is that selection that they make, or the decision that is made, is often a reflection of where they perceive the demand to be. All right. So that by doing that, they're signaling their true feelings about the demand. So the supplier would say, "Hey, if you purchase this much capacity, here's the price. This much capacity, here's the price." And so you provide a menu of capacities and prices. Advanced purchase contracts. So in a case like this, you offer an incentive to the retailer to purchase a certain amount of capacity, and before you actually go ahead and build. And again, whatever they decide to pre-purchase often it would be a very conservative amount. They wouldn't want to take too much risk ahead of time, and so therefore they're signaling what they believe the true demand might actually be. Excuse me. If we could improve forecasting at the retailer, at the distributor, and certainly we could reduce the effect of variability in the supply chain, and that often requires some sort of cooperative forecasting systems where the partners in the supply chain agree to work together to firm up the forecast. So a retailer and a distributor will actually share their forecast with each other, and sort of work on coming to some kind of consensus on what they believe the true demand actually is going to be, and on that basis plan the supply chain. So that is a sort of a much more collaborative process, which could help to improve the accuracy of forecasting, and then ultimately reduce the bullwhip effect. So excuse me. Information of coordinated systems is an important requirement in supply chain management, because you have various facets such as manufacturing, you have storage, which happens at the distribution centers and warehouses, and even at the retail centers as well. So all of that has to be coordinated to allow the entire supply chain to be a whole lot more efficient. and that we must recognize that the output from one system is the input into the other. So the output from the manufacturer is so that buffer inventory is the input into the wholesaler, and the output from the wholesaler is the input into the distributor, and so on. So each of these stages have some kind of interface or some interaction, and often because you have independent partners, they are trying to optimize their own objectives, and if there were no trade-offs, then it would be relatively easy. But the reality is that there are some trade-offs that happens, and as a result of that, we tend not to get a globally optimized supply chain. We would typically get a locally optimized supply chain, because each person is doing what is best for them. If we could actually deal with global optimization, there are some issues, of course, is that who will actually do the optimization, and if there are savings to be gained, how do you share it among the partners, and so on. So you could use supply contracts and strategic partnerships to certainly help alleviate that problem. All right. So sometimes you could try to meet when customer demands happen. When customer demand happens, if the company has multiple stores, usually the customer just wants to know that they could get the product relatively quickly, and so you might be able to fulfill that order from another store, the inventory of another store. And so in a case like that, the ability to locate a potential source of that item is actually quite important. If the store runs out of stock, it could get it from another store. So for example, Long and McQuaid, if they run out of stock, could get it from the Dartmouth location or get it from the Sydney location, and so forth. Right? You could attempt to try to do some inventory pooling, which helps to minimize the impact of variability, because remember, inventory pooling helps to bring the highs and lows to a kind of a bit of a washout. And if that happens, then you have lower levels of variability, which then allows for better planning in the supply chain. All right. Try to focus on lead time reduction, because we've already shown that the Bullwhip effect is a function of lead time. The longer the lead times, the greater the Bullwhip effect. And so trying to find ways for suppliers to reduce their lead times. So typically retailers would have a tendency to want to search for, as part of the decision process in selecting vendors, would look for suppliers that could actually meet lead time requirements, short lead time requirements. Information, sometimes there's some trade-offs that happens as a result of exchanging information. So again, because it's possible to have partners with conflicting goals, it is also possible to have trade-offs in the kind of information that is provided. So while information might serve one particular partner, it may not necessarily be helping the others. So again, this just sort of speaks to the complexity of supply chain management, particularly when you have independent partners in that supply chain. So if you look, for example, the people who supply raw materials, their wish list is very different compared to the manufacturers, compared to the retailers. Retailers want short order lead times. They want an efficient, accurate order delivery system. Well, if you think about it, you go backwards, you have materials warehousing and outbound logistics. Well, they want to minimize transportation. So if you're going to try to minimize transportation costs, for example, then what may happen is you may want to wait till you have economies of scale. You might allow inventory to pile up and then do full truckloads. Full truckloads of delivery allow you to sort of spread the cost over all of the items. However, that does not enable shorter lead times for retailers. Right? Customers want in-stock items. They want a lot of variety. They want low prices. Well, variety and cost. Sometimes, the greater the variety, the greater the cost. Greater the variety, the greater the uncertainty. Greater the uncertainty requires safety stocks, and then safety stocks, of course, drive costs up, and so on. So these different stages all have their own objectives, and sometimes those are not necessarily met very easily. Right? Lot sizes, of course, lot sizes provide economies of scale, but at the same time, that does not allow you to be responsive if you're going to produce very large lots. So manufacturers typically will want to produce large lot sizes, large production runs, because their capital costs are so high, and they want to spread those. But then there are some techniques, just-in-time systems, that allow you to use much more of a pull system and reduce the amount of, in other words, move to a sort of a demand pull rather than doing sort of a make-to-stock kind of a policy at the manufacturer, which then leads to large inventory levels. Okay. If the manufacturer has a fair amount of information and enough of a lead time, then they could often plan production in a way that minimizes costs for them. All right. Also, too, in terms of if data is shared, in other words, if a distributor can see the manufacturer's inventory, then they're better able to predict lead times. And similarly, if the retailer can see the distributor's inventory levels, they can sort of predict lead times a whole lot better and offer better service to customers. All right. In terms of transportation, there's a tendency to want to have full truckloads because they reduce transportation costs. And so, again, if you are trying to achieve full truckloads, you might actually negatively impact lead times because you have to wait till you get enough stock to do so. So there's a trade-off between transportation costs and inventory costs. So you would increase inventory costs by waiting on stockpiling, but then you could reduce transportation costs because now you have full truckloads and so on. So again, trade-offs exist in lots of places. Lead times. So when customers want short delivery lead times, that means you have to deliver frequently to them. If you deliver frequently, then what happens, of course, is that you increase your transportation costs. If you want to hold inventory items to get the economies of scale for transportation, then of course you have impact in lead times. So when short lead times are necessary, they tend to drive transportation costs and vice versa. The more product varieties that you have, what tends to happen is that you would then need to keep safety stock of all of these different product varieties, so that drives your inventory up. Okay, if you want to meet a certain service level, you will find that with greater product variety, it's a lot more difficult to forecast demand, and therefore, because of the demand uncertainty, or because of the errors in the forecast, there's a tendency to keep more inventory as a result of that. So it is certainly a trade-off between having more variety. More variety is good for customers, but it actually drives the cost up for your retailers and the other partners in the supply chain. One of the ways of dealing with that is something called postponement or delayed differentiation, where essentially you make a product as generic as possible, so you do some inventory pooling as a result of that, and then you do the differentiation as late as possible. So if you're making ski jackets, as in the case of Sport Obermeyer, you would keep the basic fabric undyed as long as possible until you receive the actual orders of the particular styles, and then you could finally sew. Because you have actually you have sort of started the production process up to a point, then you cut down the manufacturing lead time to some extent, and the lead time then becomes the time that it takes to do the differentiation when the actual order is received. Wendy's, for example, in terms of their whole strategy, does something like this in terms of delayed differentiation when it's producing a burger. Wendy's used to market themselves as being able to customize the burger, give you the burger that you want. Well, why? Is because they partially cook the patties, so that is undifferentiated at that point, since you use the same patties in pretty much all the burgers. So that cut down on the production lead time somewhat, and then when the order is received, that's when they finish cooking the patty, and then doing the and then adding the different condiments that you want. So there's delayed differentiation in a case like that. All right. Another trade-off is a cost to customers. So reducing inventories, manufacturing costs, and transportation costs can actually require compromise with customer service levels. Because, for example, if you want to reduce inventories, then the risk of stock out is greater. If you want to reduce transportation costs, then again you wait for items to stockpile. Waiting for them to stockpile means that you are going to increase the lead time. Increasing the lead time then means that you may not be able to be as responsive. Now, if you increase the lead time, then there may be a tendency to want to keep more inventory at the retailer because of that increased lead time. And in doing so, you actually are driving your inventory costs up at the retailer. So cost and customer service actually does have some trade-offs and so forth. Just something to keep in mind that at some point in time, too much information is not good. So it's good to have information. It's good to share the information to allow for better planning. But then information collection is not free; it comes at a cost. And so it's important to determine what information is absolutely necessary to be shared among the supply partners so that you get the best bang for your buck. In other words, you don't want to overspend on the creation of information that is of little value in terms of reducing supply chain costs. And so in summary, we have the Bullwhip effect suggests that variability will increase as we backward propagate into the supply chain. This variability is caused by a lot of is caused by several factors, and this variability does have the effect of creating what we call operational inefficiencies. There are several strategies that can be used to counteract the Bullwhip effect, because if you don't, the added cost of inventory in your system can sort of wipe out some of the margins that can be made from the supply chain. So sharing information certainly assists with that, providing incentives to share credible forecasts, and then alignment of expectations associated with the use of the information. In other words, don't produce more information than you actually need. All right? Understanding the interaction of the various supply stages and their trade-offs, particularly in an environment where they are independent operators, and then working to try to reduce the degree of the trade-offs necessary can certainly help to improve the performance of the supply chain.